Hey friends, welcome to my channel. Welcome to another video of the stack playlist in DSA. I am Diptangshu Rai and now I am going to say about the next topic, that is next greater element in the stack. It is one of the famous questions in the campus interviews, not only in the campus interviews but also in many coding rounds and online coding rounds. This type of problems actually comes. So that problem is next greater element. The next greater element is actually the problem of monotonic stack. The next greater element is actually, we will say, the problem of monotonic stack. Monotonic stack. So this is actually a monotonic stack problem. So this is actually a type of monotonic stack problem. So what is the next greater element? Suppose, let us consider that you have an array. Let us adjust it. Suppose you have an array, that is ARR array. Array is equal to, that is, suppose you have an array that is equal to this. This array elements is no, I don't want underlines. Why underlines? I don't want that. Suppose you have an array that is 6 6 0 6 0 8 8 1 3. So suppose this is an array that is 60813. In this case, how I will get the stack? Then what will be the answer? So this will be the answer. That is 6. If I am standing at 6, so how you will frame the answer? In this way. Right? Okay, so in this case, how you will frame the answer? Just look at my cursor. In this case, first I will go to the 6. Okay, in case I found that if any of the elements is greater than 6, suppose I found that this is a stack array. In this case, wait, suppose there's a 6. In this case, 6. I'm standing at 6. I will standing at 6, from the next position I will find that whether if any of the element is greater than the 6 or not. If I find that any of the element which is greater than the 6, I will put. I find that the element that is 8 is greater than the 6, then what I will, what value I will put here? In this case, that is this the stack value, then 8 value I will put here. Okay, and after that, I will move my cursor to next pointer. That is where I will move the cursor here in 0, and from the 0, and that is from the 0, uh, after the 0, the next elements which I found, which of the element is greater than the 0. I have to find, when I will stay on one element, I have to find that which of the element is greater than that of that of the element which I am present. So I will find it 8. So here again, the next value in the stack will be 8. Okay. So here the next value in the stack will be 8. After that, if I am standing at after that I am standing at 8, what is the next value? Greater than 8. Greater than 8. So I cannot find any value which is greater than 8. Since I cannot find any value which is greater than 8, so now what my value will be? My value will be, my value will be, my value will be -1, because I cannot find any value greater than that of the 8. Okay, if I'm standing at 8, if I find that any value which is greater than 8, so I cannot find any value greater than 8, so I will keep it as -1. After that, if I'm standing at 1, same thing. If I'm standing at 1, in the right of 1, which is greater, that is 3, so I will put here 3. So I will put here 3, and after that, and after that, 3, after the 3, in standing at 3, suppose I'm standing at 3. If I'm standing at 3, suppose, see the cursor. If now I'm standing at 3, what elements are there in the right of 3? No elements are there in the right of 3. So in that case the value will be nothing but, the value will be -1. Okay, so in this case the value will be -1. So So that will be minus 1. So you will say that, hey, which is the answer? The answer will be this one. This one will be the answer. That is the that is the complete array. That is the stack array. That is the stack array which I'm supposed to write there, is actually this type of array. That is here. That is here. It is actually 8. That is actually let me change the color. In this case, I have 8, 8 minus 1, 8, 8 minus 1, 3 minus 1. So this is actually the stack. That is 8, 8 minus 1, 3, 1, and this is my answer. Okay, so this is my answer. So how I will reach the answer? So what will be the extreme brute force solution? What will be the extreme brute force solution? Let me see. So so what will be the extreme brute force solution? In this case, let us find the brute force brute force code, and then I will move to optimize code. So let me tell you what is the brute force code. In this case, the brute force code will be, suppose I have taken or NGE. The next element, that is n. Suppose I have taken NGE, that is n array. Okay, n array. Initially I will take for int I is equal to 0, I is equal to 0 2. I'm just writing the pseudocode for int I is equal to 0. Oh, my bad. I I is equal to 0 2 which part? N minus 1, bro. Okay, so n minus 1. Okay, after that next, that is standing at 0. So I am searching the next element. So what will be my next element? That will be I plus 1. So I will run another loop for finding the next element. That is here for j. That is here for int j is equal to I plus 1. That is for the next element. I plus 1 2 n. Okay, so j will also, sorry, my bad, n minus 1. Okay, so in this case, so then the case, if any condition I can find that if array of I, if array of I or array of j, I find that given element is greater than that of the present element, that is array of j is greater than array of I. In this case, what I will do is that ng getter, one minute, that what I will do is that ng getter, that is nge, that is nge, in next getter element I will put the element of array of I. So sorry, my bad, array of j. I will put the element of array of j, and after that I will break, and after that I will break. Just after that, I'll close the if statement. I will close the for loops. Okay, so closing of the for loops, I will now do return nge. Okay, return nge. Okay, so this is the two for loops. So this is the closing bracket of the two for loops, and after that this is the closing bracket of the if statement, and this is the closing bracket of the function. This is the closing bracket of the function, this one. Okay, so this will be the brute force solution as we traverse all the elements. So I will say, what will be the time complexity here? In this case, what will be the time complexity? I will say that the time complexity will be here for one loop and two loop. They will be big O of n squared, big O of n already square. Okay, so the time complexity in this case will be big O of n squared, and this in this case it creates a problem because it takes big O of n square, and the interviewer will not be happy with that. So we will move to the optimized solution. So let us see the optimized solution. So how I will write the optimized solution? So the optimized solution is simple. Suppose, in order to understand the optimized solution, I have to I have to take a big size array. For example, I am taking an array So so I have taken an array, and I will insert elements into the array like this: 4, 12. Sorry, let me check. So here I have taken a simple array in this case. So how I will approach in this array? So how I will approach in this array? Let us understand. First I will zoom this part and more. So how I will approach in this array? First I have to take a stack. So let us take a stack. So this is a stack. So in this stack what it happens is that first of all I will take, okay, in the stack it will be visible. In the stack what I have to do first. First, what for the main question of arising, that from which part I will traverse, whether from this part or from this part, whether I will travel from left to right or from right to left. The reason is that if I traverse from left to right, in this case what happens is that, for example, first I will traverse in 4, then I will traverse in 12. Suppose I want to traverse in 1. Okay, so 5, 3 and then 1. So when I will traverse in 1, I'm not getting the track. Okay, I'm not getting the track of this. So how I will get a track of this? I'm not getting the track. Yeah, I'm not getting the track because I am starting from left to right. Okay, I am moving from the position from left to right. Since I'm moving from the position of left to right, I'm not getting the track of this. So since I'm not getting the track, so what I will do is that I will the main intention is that I will move from right to left. Yes, right to left. So how I will move? For example, I will take a for loop which is of the backwards. Initially I will stand at 6. Okay, so when I will stand at 6, what I will do is that when initially, 1 minute. So when initially I will stand at 6, first I will mark this 6 and make it as -1. Okay, since this is a stack, that is the stack st, and there is no element are present in the stack, and after that, and besides that, the elements in the right of 6, no elements are present. Since no elements are present in the right of 6, then it will be -1. Minus 1, that means in that case, after putting -1, I will put 6 here. Okay, no problem. 1 minute. So I will put 6 here, and this is a stack st. Okay, so what I will do is that after putting -1, I will remove this part. Okay, so 6 is done. After that where I will go? After that I will go to the 4, and then I will search in the top of the stack which element is present in the top of the stack. 6, sir. So 6 is present in the top of the stack. So this will be -1, and there will be 6 because 6 is present in the top of the stack. Not understanding the text, let me write it like this. So so I will search. So if I traverse to 4, I will search that which element is present at the top of the chest. 6. So is I will then after that I will check, is 6 is greater than 4? Yes, 6 is greater than 4. Since 6 is greater than 4, then I will place 6 here. Okay, let us make the value smaller. So I will place 6 here. Okay, I will place 6 here. So the process is done. After that, what I will do is that I will move the cursor to here. Okay, after I move the cursor to here, sorry, not cursor, the pointer, and after that 4, I will insert 4 here. Okay, so I will insert 4 here. So after inserting 4, if I were to do, I will search at the top of the stack. In the top of the stack, I can find that the element 4 is the element 4 is greater than 2. Yes, it's greater than 2. If it is greater than 2, then no problem. Then you will place 4 here instead of 4 here. Okay. And after that, that the 2 which is there, I will insert this 2. I will insert this 2 where? I will insert this 2 into the stack. So I have inserted 2 into the stack. Okay. So I have inserted 2 into the 2 into the stack. So done and dusted. After that, what happens? After that, what I will do? I will move to 4. Okay. Sorry, I will move to 1. Okay. If I move to 1, I will see that if 2 is greater than 1, yes, 2 is greater than 1. So since 2 is greater than 1, what I will do? What I will do? I will insert 2 here. Okay. I will insert 2 here. Okay, I will insert 2 here. So and after that, what will happen is that 1 will be placed here. Okay, so yes, so what will do? 1 will be placed here. So in this case, 1 will be one will be placed here. Okay, so here, now here the twist occurs. What happens is that if I'm in the 3, okay, if I'm in the 3, I will find that which one is at the top of the stack. In the top of the stack, I will find, wow, I found that 1. And after that, I will confirm that if 1 is greater than 3, if 1 is greater than 3, no, 1 is not greater than 3. In fact, a 3 is greater than that of the 1. If the array element, if the array element is greater than that of the 1, okay, if the array element is greater than that of the element which is present in the stack, what will I do? I will pop it. Just think in simple terms. That means if I have 3, suppose I have a graph. If this is suppose this is 3. If I have 1, okay, this is 1, and another. If there is 2, okay, 3 plus 3, 2, and after that I have one, that is 4, and after that I have another one, that is 6. So will consider? I won't consider. I will consider if I am standing, if I am standing in the pole, I can see what I will see. If I am standing here, what I will see? I will see after 3 4, and after 4 6. I won't see 1 and 2. So in that case, we won't consider 1 and 2. I am repeating it again. Suppose you have one pole. Okay, there is one pole, that is a pole of 3. Okay, and I have one pole that is of 1 pole, and I have another pole that is of 2 pole, and I have another pole that is of 4 pole. This is of 4, and this is 6. Okay, let us number. Let us number this pole. Suppose, 1 minute. Suppose this is 3. Suppose this is 3. Okay, suppose this is 3. Suppose this is 1. Suppose this is 3. Suppose this is 1. Suppose this is 2, and this one will be 4, and this one will be 4, and this one will be 6. Okay, so in this case, in this way, so if I'm standing at 3, I cannot see 1 and 2. If I'm standing here, okay, suppose this is me. Okay, so it's me, I'm standing here. Okay, okay, if I'm standing here, bro. Okay, if I'm standing here, I can see 3. After that 4. After that 6. But can I see this one? You can think it logically in this way. Can I see this one? I cannot see. So since I cannot see, then from 3 to 4, from 4 to 6. Okay. So in this way. So what I will do it. I will discard it. Okay. I will discard it because I will see in this fashion. Okay. So in this way, what will happen if 3 is present? If I find that find that is greater, so 1 and 2 will be eliminated from the stack. 1 and 2 will be eliminated. That means simply, in simple terms, it is popped out from the stack. After it is being popped out from the stack, which element I found which is greater than 3, that is 4. Then I will insert 4, no problem. And after that, and what happens, the 3 will be, then after that, what happens, the 3 will be inserted into the stack. Okay, let me take this one. The 3 will be okay. So 3 will be inserted into the stack. After that 5. Okay, after that 5, I will come to here again 5, and I will see that 3 and 4. So what happens, 3 and 4, so I can so if I come, so 3 and 4 both will be removed. Why both will be removed? Because both elements are because both elements are smaller than that of the 5, so both are removed. And what will happen in this case? 5 will enter here. So 5 will enter here. So what will do? 5 will enter here, and in this case, which will be the next greater element? This will be 6. Got it? Which will be the next greater element? 6. So till now I got minus 1, 6, minus 1, 6, 4, 2, 4, and 6. And after that, what I will do, I will move to next element. That is I have moved to 2. Okay. Which element at the top of the stack? 5 is top of the stack is 5. Is 5 is I can 5 is 5 is greater, is 5 is greater than that of the 2? Yes, is greater. Since 5 is greater, so what I will do, so I will insert, so here 5 will be inserted. Okay. So there should not be any problem, because 5 will be inserted, and here 2 will be inserted. A simple case, 2 will be inserted. Okay. Okay. And after that, 1. Okay, 1. So in this case, and after that 1. Okay. So after 1, so in the 1, what I will do is that, in the 1, which element is on the top of the stack? 2. If 2 is greater than 1, yes, 2 is greater than 1, then there is no problem. Then you will place 2. Okay. And I will place 1 here. There is also no problem. So here it is. So we in this case like that. After that, encounter 3. If I encounter 3, the same. If I encounter 3, okay, I will find it. I will find it 1 is less than 3, 2 is less than 3, but 5 is greater. So I will put here 5. So here I will put 5. So here I put 5. Why? Because the first two elements are popped out. Okay. After that, simple in case of 5. Okay. So what happens that I'm in the 5. So since I should be greater than, I should not be equal, so what I will do, I will pop the element of 5 and place the element which is 6. That means here, which element will be placed? Here 6 will be placed. Okay. And 6 will be placed, and the element 5, 6 will be placed. And what will happen? The element 5 will be entered. Okay. That means again the element 5 will be entered. Okay. I am in the 12. I am in the 12. So I will find that, so when I am in the 12, I will find that none of the elements are greater than that of the 12. So I will pop out 5 also, I pop out 6 also, because I found that 5 and 6 are less than 12, and none of the elements in the stack is greater than 12. So we can find that the stack is empty. In case if the stack is empty, so what I will do, that is simply minus 1. Okay. And I will place the element into the stack. Just after, in case of 6, in the right of the 6, no element. That means minus 1. After putting minus 1 is 6, I put the element in the 6. Same case I have done, that when the stack is empty, I put minus 1, and I put the 12 element. Okay. And in case of 4, which element is greater? Is the top of the stack is greater? Yes, the top of the stack is greater. So what I will do, I will put 12. So what will be the new array? So what will be the new array? And what will be the new array answer? The new array, that is st. Suppose that this new array will be what? 12. That is 12 minus 1, 12 minus 1, 6, 5, 2, 5, 6, 4, 2, 4, 6, minus 1. Okay. Let me check if there's any problem. 12 minus 1, 6, 5. 12 minus 1, 6, 5, 2. 12 minus 1, 6, 5, 2. 5, 6, 4. 5, 6, 4. 2, 4, 6, minus 1. 2, 4, 6, minus 1. Yes. Yes. So, 1 minute. Type was So this is a so this will be the so this will be the answer. So what will be the optimized code? Now let us see that optimized code. So what will be the optimized code? As the interviewer wants to reduce this big O of n square. So in order to reduce this big O of n square, what will be the optimized code? Let us see. So I will take list. So I will take list, that is int find ng, find ng. Okay, I will take array, any kind of an array I will take. Okay, so after taking an array, what I will do is that ng, that is ng of n, I will take an array that is ng of n, ng of n, that is an array. Other I will take stack, I will take stack int st, that is normal standard stack which we used to take in case of by using STL, the inbuilt function, that is stack. Now for int I is equal to 0, I is equal to I is equal to, that is I am reverse, that is I am traversing from the backwards. I is equal to n minus 1, n minus 1 2 0, because I am because I am traversing backwards. Okay, n minus 1 to 0. Okay, so I will find that while not equal to st dot empty. Okay, if I find that if y is not equal to st dot empty, if I find that a stack is not empty, that means some of the elements are present inside the stack, and and the top elements and the top, and the top element is less than is equal to array of I. Okay, which I am saying that if the stack is not empty, if or that means that if the stack has some elements, and I am seeing that the top of the stack is less than that of the elements. On that case, what I have told that simply to, on that case I told that simply I will pop the elements, that is st dot pop. I will pop the elements until the elements which are smaller than that of the elements in the elements in the stack which is smaller than that of the array, that is st of top, that is the elements which is present in the stack is smaller as compared to that of the array. On that case, in that case I will pop those elements out, as simple as that, which I was doing. Okay, so another case, if so another case that if st dot empty, why st dot empty? St dot empty is actually, if I find that stack is empty, that means in the first case, in that sixth case, remember, if stack is empty, then return, that is, sorry, not return, that is NGE, NGE, that is capital NGE, capital G, NGE of I. No, I've taken small. So NGE of I, that is NGE of I is equal to minus 1, because I'm putting minus 1, that is this the ng array, this is the ng array, and this is the answer array. Ng array which is present, ng array is the answer array, and this is the original array which is actually provided. So so this answer array I will put minus 1. Why I will put minus 1? Because no element is present. Same in case of 12, and if all the elements are popped and the stack is empty, on that case I will put minus 1. Okay, otherwise else what I will do is that in else case I will if the stack is not empty, then those elements are elements which are in the stack, in the stack they're greater. Okay, so those elements are greater. So otherwise those elements are greater. That means is the top, that is the top element which is present, I will put that top elements into the next greater element stack. Okay, as simple as that. Wait a minute. Then what I will do, that that what I will do, that I have first while loop actually filters out those elements which are less than that of the stack. The first while loop actually it tells that it checks that if the stack is not empty, along with that means it consists of some elements, and those elements are less than that of the current position of that array which I am standing. On that case I will pop those small elements which are smaller than that of that array. So in that case I will pop those elements. And another statement filters out those elements, that is if the stack is empty, in that case I will put -1. Else those elements are present, so naturally those elements are present which are greater than that of the element. Naturally, so those elements are present in the stack. The elements which is present in the stack is greater than that of the elements which is present in the given array. The elements in the stack is which is present now is greater than that of the elements in the given array. So in that case, what happens? Ng of I is equal to to the top. Okay, the remaining elements are there. And then what I will do is to the push. And what I will do is to the push array of I. So what I will do in that case, I will push the elements. I am already filtering out, and after filtering it out, that means those elements are remained which are greater. That means which are greater. Those elements are present in the stack which are those elements which are present in the stack which are already greater. 1 minute. So in that case, what I will do? That means I will push the elements, that is st dot push. That is I have done st dot push of array of I. Okay, I push that elements. Okay, so I pushed that elements I pushed that elements, that is st dot push, that is array of I, and after that I will return ng. Okay, so that will be the optimized code. 1 minute. Um, now it's completely fine. So that will be the so after that I will return this ng array. Okay, so this will be the optimized code for this. So so this will be the optimized code of this. Now what is the time complexity? Okay, so this is the last part, that is what is the time complexity. That is a time complexity which I found is that time complexity, that is big O of, that is, sorry my bad, big O of 2n. So why big O of 2n? Big O of 2n because in the from the first for loop it will find for big O of n. Okay, and in the next and this big O of n, so many of them will say big O of n square. No, it's not big O of n square. That is, it is one for loop, that is here big O of n, another for loop, that is big O of n, another, sorry my bad, while loop, that is another big O of n, that means big O of n plus n, that is big O of 2n. Okay, so in that case the time complexity will be reduced from n square. That is for this case the time complexity will be reduced from n square to 2n. So that's all for this video for the monotonic stack. For monotonic stack, next greater element. If you find this video helpful, so please like, share and subscribe to the channel. Thank you.